Hey everybody, how are we doing today? Just replying to some emails. Sorry about the small delay there. What do people want to do? Good to see you here, Aubrey, Demetrius, Chimera. Good to see you here, Caroline, Madeline, Josephine. Good to see you here. What would people like to do? It is your call. I was checking out all the things right here. Did everything get resolved? Checking out the emails, test day emails, making sure everybody's on track right here. And then I get random emails from Pearson. Your call right here. Let's see right here. And if you have questions, let me know. Let me cancel out of my emails that I sent everybody. Got all these exam reminder emails I sent. So many exam reminder emails. There we go. Let's see, Chapter 5. What Chapter 5 should we do? Do you want to go over the Chapter 5 homework, or should I let me ask right here, ask the chat. Which one? Let's see here. Which one? Chapter 5 homework or Chapter 5 practice questions? So your call right here. Chapter 5 homework or Chapter 5 practice questions? So... Chapter 5, Terry sent an email. I'm looking at Terry's email. Okay, I think so. Okay, sorry. So many little things. Making sure. Okay, I see Terry did that. Good. Let's see what people will vote here in a second. Okay. Need to make one more change to a student right here. And then I will do this. Sorry, dealing with exam day. Let me make sure this is saved. And then 2 seconds. Put on a little music right here. We'll get going right here with some example questions. Really? Okay, this is loading up good. Okay. Make sure I change the right student right here. Okay. Good deal. Go. 2, 1. Okay. We can start here in 30 seconds. Oh my gosh. Today is a busy day. Okay, let's take a look. What's up? Most likely be on the practice exam questions. Let's go check this out. Oh, let's do some practice exam questions here. Brian's ready to go. Woo! Busy day. We like busy day. Kayla, good to see her. Mia, good to see her. Let's throw 100 points out to everybody. Mubot, are you awake? I think Mubot's awake. Get some coffee. I ran out of coffee. Let's go check out some exam questions here. Let's do this. Time for some exam questions. Let's see if you can solve these. Let's practice some Chapter 5. And so let's say exam scores are normally distributed. And thank you everyone for waiting just a moment right there. I replied to like a lot of emails in the like 13 minutes this existed. Like 15 emails. Okay, here we go. Exam scores are normally distributed with a mean of 70 and a standard deviation of 8. What are you going to be doing while Brian's writing this right here? What are you going to be doing while Brian writes this? Immediately, what should you be doing? Like right now, your brain needs to be like, I need to do this when I hear this. I know, right? Draw it out. So I'm trying to reply to all the emails quickly to make sure if anyone runs into any problems or has any questions or something's not right, we get it fixed immediately. So I'm doing that in the background. We're going to draw it out. And so when we draw it out, you probably want to have something like this to start. Now, you can't bring this to the exam. I keep saying you can't bring this to the exam, but you can draw this when the exam starts. We can't stop you from drawing something on your strat sheet. Now, don't bring notes. No notes on the exam, but you can draw it out. So you should start making a drawing right here. And once again, who feels like they have these questions pretty well down? Like whatever I ask you here, you're probably going to be able to solve it. We're going to use only the empirical rule numbers on this. I'll put a note up at the top. But who feels like probably you're going to get this question? Who's like, Brian, I'm feeling pretty safe on this. Does anyone feel like however I ask this question, you're probably going to be able to figure it out? Or if you're like, no way, there's no way. Maybe, Mara says, I'll take some maybes. And I bet you the people who are like, I got this, are the ones drawing it out right now. Because if we draw this out, and this is what you should do, you can always look at my drawings, but on the test, you won't have my drawings. Would email or Discord work better to contact you? Either or. I'm only at 7 messages on Discord right now. You can watch sometimes, if you watch a class, my Discord message is way up. So either one's fine. I'll try to be looking at everything. Sometimes I do eat dinner, or I do hang out with my fiance, so I'm not always available. But I try to be as quick as I can on replying and as thorough. And it's hard to be quick and thorough at the same time. So we're going to only use this right here. But yeah, Zoe, just contact me and I'll try to get back to you whichever way possible. Don't contact me on both. That just creates more messages. Only contact me on one and I'll make sure to get back to you. And so now let's ask a question. What percent of students score above a 78? I know I did eat. I got a snack and I ate. Snack's over. And then I replied to emails. Went, got a snack, ate snack, replied to emails while eating snack. Multitask. That's how you win right there. 50 points right there. I went and grabbed a snack real quick. 16%. You got it. How'd you get that? How'd you do that? Who does not understand? Say me in the chat if you don't understand how to solve this. I could do a different one. Who, if you don't see how to get the 16%, say me in the chat. It's all right. I'm gonna throw some points if it'll say me. It's all right if you don't know how to solve this. The goal is we figure out how to solve these things and we can solve them pretty quickly and be like, okay, now some people will need to draw it out, some people won't. It helps to draw it out to see exactly what we're looking at. Don't worry, I'm gonna still throw some points out here. So let's take a look right here. The first thing we should need to do, yep. It helps so much because then when you draw it out, well, one, you can see that this is at a z-score of 1, which means that exam score is 1 standard deviation above the mean. So we're going to put a line right here, a blue line, and our blue line will show us where we're at, and we're right on an empirical rule number. And since we're on an empirical rule number, we can use the 68, 95, 99.7. And you can use the percentages between here. So if you do have the percentages between here, I'm going to use my nose. So if you have the percentages between here, you would be able to use the 13.5, the 2.35, and the 0.15. Now, it's also probably a good solve to do the following. Another solve I like is to say 68% is between here. So what is total outside of this? What is total outside of this? If 68% is between my hands, what is total outside of it? What is total outside of it? What is total outside? 32. Great job, Demetrius, right there. Some points. So if 32 is total, and great job, Camara, showing it right there how to solve it, then we just take that and divide that in half, and we could see that this is 16%. So now we could change the question slightly and just do a different version and say what percent are expected to score below a 78. So what percent are expected to score below a 78? So who knows the answer to this one? Try to solve it in the chat right now. Below a 78. I need to look up why does Microsoft Word change pen colors? Maybe they'll solve that with Windows 11. That'd be great. What percent are expected to score below a 78? So we know 16% is above a 78. And that's the answer to the below right there. 84, you're getting it. You're gonna. I hope you just crush these questions. Once again, it just comes down to practice. Try to come up with a more difficult one. We have pictures from class. We were doing just different examples, so I could probably come up with a different example using a class picture that we did. Did we delete those? We deleted them. Let's go grab a David M. Lane picture here and practice what it could look like with a picture, because there's about a billion ways to ask the picture way of doing it. Now, you won't use the applet during the test. What will you do during the test? You'll look at pictures. Just like your Canvas content, Canvas contents are the best way to know what the exam will look like. Can't say that enough. The better you're doing on Canvas content, the more prepared you are for the exam. If you're making 6s or 7s or 8s on Canvas contents, that's what you're tracking towards for the exam, and it might be a little bit lower on the exam because Canvas contents are open note. So every time you do a Canvas content, write down the questions, use your notes, use videos if I'm doing a Canvas content in a video, and practice them and understand the theory behind them, because the test questions are based on Canvas content questions. So if we were to have a question that said something like this, we'll do an easier version right now. Let's go and we'll do this. Okay. So I want to know what percent of students, I'm going to take a picture here and bring it over. Two seconds. Didn't get the picture I wanted. No, there we go. Gotta get the perfect picture. It's sadly an obsession of mine. Okay, so let's bring this picture right here and let's take a look. This is what I need practice on. Good stuff right here. Can you go over there between David and Lane graphs? Like what? Oh yeah. This one right here. This one is below. So what are we viewing right here? Let's Catherine, good question. So what are we seeing right here? Explain to me in a sentence what we are observing. Like how is Brian going to write this test question right now? How is Brian going to write this test question? We're going to say Stat 201 students took an exam and what, and I could very easily, this percentage right here is talking about what? Like I'm going to change up and make it a little more difficult than this, but what does this mean right here? What does this mean? Like, tell me all of these values and what they mean. Like, explain each one of these values and the purpose. Now, these other values, sometimes we blank them out so you don't see them because they're not needed and we don't want to confuse people. We do sometimes remove them from screenshots, just takes a little bit more time. So really, those are the only values we're focusing in on. Explain to me, like, could you interpret what this graph is saying right here? So the top part of it, the parameters, tell you the mean. Careful, you're close. You're very close, Kayla. Not the above a 62. Look at the way it's shaded. Look at the way this is shaded. You're right there, not above a 62. And not, be very careful, so we're close. Here, I'll interpret it in a second. I want to see what people are saying. Let's see if someone gets it. I'm going to throw some points out. We'll throw out some more points anyways. But what does this mean? Zoe, you're right there. That's correct. And so this would be the percent of students who score below a 62 on a test with a mean of 75 and a standard deviation of 5. And this is just what we observe, like below a 65, or 62, excuse me. And this is going to be the probability of it. So does that make sense right here? 9.682% of students are expected to score below a 62 on a test that has a mean of 75 and a standard deviation of 10. Let me repeat that again. 9.68% of students are expected to score below a 62 on a test with a mean of 75 and a standard deviation of 10. Does that make more sense, Catherine and everybody? Like how to read it? How does then go to the percentile questions? Let me ask kind of this is maybe a multiple choice question we could put on the exam. And I'm going to have to think of the answer here real quick. Little more difficult. So use the graphic below to find out where the 90th percentile would be close to. Okay. Use the graphic below to find out where the 90th. This is a little more difficult of a question. Use the graphic below to find out where the 90th percentile would be close to. So if we had multiple choice right here, multiple choice could be something like, I have to think of the answer. Give me a second. Okay. So multiple choice could be something like 81, 83, 85, 88. So here's your multiple choice possibilities. And no, we don't want to do that. So here's your multiple choice possibilities. Does anyone have any idea how we could figure this out? This is a little bit more difficult, I will admit. Don't want to do that. This is a little bit more difficult. This is probably one of the hardest ones I've asked. But does anyone have any idea how we could find out about where the 90th percentile is? Little more difficult. This one is a harder question to figure out about where the 90th percentile is. And usually we give a graphic that's more towards the answer. So what are we seeing right now? What percentile are we seeing on this graphic? The percentile on this graphic is the what percentile? Currently on this graphic, if it would let me draw an erase, the percentile on this graphic is the what percentile? Really? The percentile on this graphic is the what percentile? Sorry, wouldn't let me erase that. Almost the 10th. Does that make sense? So this is almost the 10th percentile. So let's put here a sign that says that this is about the 10th percentile. Like that's about the 10th. So I want to ask you this. So it's very close to, it's the 9.75th percentile to be exact, or 9.68% percentile to be exact. So it's the 9.68th percentile. You have to be careful though, because the percentile means the area what on the curve. When we talk about percentiles, it's the area what on the curve. Kayla's already figured it out. We'll show how Kayla got that here in a second. Great job, Kayla. 100 points. Great job, Kayla. You are correct. It's the percent below that. So when we think about this, all we want to do is we want to take this curve and flip it. Because if we want to be about where the 100th percentile is, or 90th, oh my gosh, I can't speak today. If we want to be about where the 90th percentile is, it would simply be on the other side. Does that make sense to everybody that the 90th percentile, if it's that's about 10%, the 90th percentile is going to be about on the other side? Who's following that logic? Does that logic make sense that that's where the 90th, because if there's 10% above that, there'd be 90% below. And since we're saying this is about 10%, that'd be about 10%. And it's just the other side of it symmetrically away from the mean. Does that make sense? Good job right there. So that makes sense. So we're going to just draw this right here. We're going to draw the same thing on the other side. And we're going to go over here to this and say we'd be about here. Now, here's the thing. If you look at this visually, make it look even better. Visually, you kind of have the answer right here. So visually, you can look at this. Oh, yeah, it would be right about there. There we go. So visually, the answer should be apparent by now. Oh, yes, he did. I did the 110th, which is not exactly. And so visually, you can see that it's going to be, 85. Well, you can just tell. You can just well, it can't be 85. I should have made more difficult questions in here. I should have put 86 or something. Because, yeah, so if you had an 86, you'd be like, well, how would I know it's not 86 now? And so now you're like, well, wait a minute. Now I have two choices it could be, right? Did I draw my drawing well enough to deduce whether it's 88 or 86? Now you're like, I don't know. So this is where we got to use some tricks. We know that we're going a symmetric distance away. So how much lower is 62 from the mean? 62 from the mean has a distance of what? What is the distance that is away? That is how much below the mean? How much below the mean is this? How much below the mean is this? 75 and 62. And we know that this is 62 because right here, that's why I'm putting 62. We know this is 75 because it's the mean. And that's 13 away. So how could we solve, if that's 13 below, how could we solve for what the answer is to the other one? How could we solve what the answer is to the other one? How would we know what the answer is to the other one? Exactly, Zoe got it right there. We're just going to add. So instead of, and Demetrius, great work right there, everyone some points. So now we're just like, oh, well, if that's 13 below, then this has to be 13 above. And so we just saw right there, great job, Molly, excellent work. So this is just showing right here the answer. And if you are trying to do problems like this, like if you're writing your own, which would be super cool, you go right here and actually check it. And you could go right here and say, let's go to the 90th percentile on a curve with a mean of 75 and a standard deviation of 10. Oh, that's the 90. That's not the 90th percentile. There it is. And it's right at about 88. So that's not exactly it, but we could say it's very close to which of these numbers. And then you would have to say 88 because that's what it's super close to. It's basically right there. So good work. Good, tricky question right there. Let's do another one. So I'm going to do a totally different type of question right here. Good solve and practice that. That's good work. Let's find out. Okay. Here's another question. And what percent of students that would get the 90th. Correct, Kayla, right there. That would get the 90th. That would mean it is the 90th percentile. Well, that's just going to tell you that is the 90th percentile. But that's not going to guesstimate 90. That's just telling you that is the 90th percentile. Does that make sense, Kayla? So that's not saying what the answer is. That's saying when you solve for this, you will be solving for the 90th percentile. I can go back and take a look, but that's what 100 percentile minus 10 will do. Is we'll say now instead of being at the 10th percentile, we're doing the 90th percentile, and then we have to find out where the 90th percentile is. Like I could show you another version of it, and we could look at that. So let's check out this one right here, see if you can solve it. Another question, next question. Here we go. What percent of students are expected to score below a 71 on this normally distributed curve right here? I'll blank out the information we don't need. So who can explain first off, what are you seeing? What does this graphic mean? I take for granted sometimes that maybe people know what this graphic means, but you are observing what right now? Explain to me in a sentence. I wish we just had write a sentence what this graphic is showing you. Write a sentence on what this graphic is showing you. So be like, this graphic is showing me the percent of students who are expected to blah, 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 on a test where the blank is blank and the blank is blank. So this graphic is showing me the percent of students who are expected to score between a... Correct, Catherine, right there. So 31.08% of students are expected to score between a 71 to 79 on a test. So I think you know it. On a test with a mean of a 75 and a standard deviation of 10. Does that make sense? So exactly. And that's the percent of the area. And 31.08. Be very careful with the decimals. Zoe right there. Good. Make sure to watch your decimals. Easy mistakes to make. And then we lose points. We don't want to lose points. Watch the decimals. You got it right there. So we are trying to find this right here. We're trying to find that. How we find that? How would we find that? Now, one thing we could do is we could actually find the z-scores for 79. Let's find the z-score for 79. Who can find the z-score? O'Brien shows the equation. Observation minus mean good practice on the z-scores divided by standard deviation. And we could find the z-score also. I'll do it in the same color. For 71. Good check for this to find your z-score, because it'll confirm something about this. Does anyone know what these z-scores are? Take a moment, solve the z-scores. I've got them in my head right now. Can you solve the z-scores? Oh, I'm dividing by 5. The standard deviation is not 5 because I was looking at it. I was like, that does not look like 0.8. It is 10 is the standard deviation, making the math nice and easy. I tried to help myself out, and then I reversed it. So what are the z-scores for these? Which you'll see an interesting thing about these z-scores. So what are the z-scores right here? Who knows what the z-scores are for these? Good practice on your z-scores to make sure you can find the z-score by saying, if we observe a 79 with a mean of 75 and a standard deviation of 10, what would that be z-score-wise? Exactly, Mia, right there. Great job, Mia. Some points in the chat. It is positive 0.4 and negative 0.4, which means that these two portions right here, these two arrows are going to be the what? If we're at positive 0.4 and negative 0.4, we're in the same spot. Oh, I don't have live chat on. I always forget. So what does that mean about those arrows, which I might have made it look not quite like it. So try to make it look more like it. What does that mean about these arrows right here? these arrows are going to have the what about them. Let's see what people think. I can solve it, but I want you to solve it. I want you to do it like, oh, those arrows are going to be what? They'll be equal. And so how much area is total for these arrows? Remember, if we subtract out the middle, we'll be subtracting out of 100%. So how much area is total under these arrows would be 100 minus the middle, because we're just finding out the outside area. And I did it 100, so I need to do 100 minus 31.8. Be careful if you switch between decimals and percentages. Exactly, Mia. Excellent answer right there. Great answer. Some points. You are correct. So I've almost got an answer right here. That's the total area for these arrows. But now what do I want to do to these arrows right here? Great job, Demetrius, also. Since we have the total area, I now want to do what to this total area? Because remember, they're both the same. The arrows are the same. They're like on the same z-score. We're going to divide by 2 because this is going to have one portion of it. Now, here's a good check. If you have these numbers right here, if you have this is equal to 34 point something, 34.46, and this is equal to 34.46, and then this is equal to, in the middle right here, is equal to 30, that's impossible to see, 31.08. What could you do to check to see if your numbers are correct on this curve? If you're like really worried and you're like, oh no, I want to find that shaded area on the left right there, but you're like, I don't know if I wrote my numbers correctly. What could you do since you've written numbers across the whole curve? I'll start doing it and explain what I'm doing to check to be like, okay, I've got this. So I'm going to go here. And then I'm going to go here. Yep, exactly. And then be like, okay, I've covered the whole curve. So we've got it. It should be 100%. Great job right there, Rad Brad. Good to see. That's like that name right there, Rad Brad. Add them up and see if you have 100%. And then Kayla's even shown we can subtract also, because we could say, and we talked about the 2 solves in class today. And so what do people want to do? Do people want to do more of these? Here's the 2 solves. You could add up these numbers, or you could subtract that from 100 because it's just the area below that. So, whoa. You want this. So you'd have to subtract this from 100. Slow down, Ryan. You can, the answer is that right there. Or you could subtract the other side from 100, which is a bit longer to add those up and subtract from 100. And if you do that right there, Kayla, you will get the area above. So the area, if you were to subtract this from 100, you would get the area above it. So the number one thing to do is to make your drawing, because here's the thing, Kayla. Right now, your answer, oh, Terry, yeah, good. Oh, Terry's class, awesome. If you were to see this right here, I want you to look at your drawing and I want you to think about something. If, and this is a wrong answer. Oh, you're saying, oh, yeah. Yep. That's how you got the areas. So if you were to get this answer for this, you'd be like, that's too big. What shall we do? We've done 2 or 3 of these chapter 5s. What shall we do? And it's your call. Let's go to the main screen. Let's take some votes right here. We're going to take votes. What shall we do? More chapter 5 practice. Chapter 6. What are people saying we should do? More tests. Which chapters? Chapter 1 through 4. Okay. Pivot. I'm putting the big things on here. Let's ask the community. It's your call. If you're here, you get the call. So being part of the office hours, you get to choose what we do. So the poll is now in the audience, or should be appearing. Click on the option you want. We'll just give it about 10-15 seconds here. So you should see more chapter 5, chapter 6, chapter 1. If you choose chapter 1 through 4, we'll start doing things from there. Or pivot. People want to pivot today in class. Oh, people saying pivot? Pivot? Might be doing a pivot review. Let's put 10 seconds on the clock. 5, 4, 3, 2, 1, 0, 5. Looks like Brian's going to be a tiebreaker here. Oh my gosh, what's happening? Pivot's losing out. Oh, let's see what's won right here. The winner is... It takes a while to show me the poll. Poll, where you at? Chapter... It's a lot of ties. Pivot 1 out, and then we'll do some chapter 6. Okay. Pivot 1 out, then we'll do some chapter 6. Let me get some pivot up real quick. So you going to load? Okay. I'm loading Excel right now. Let's hop over and do some pivot questions and talk about how to do pivot. Thank you for the 13 people interacting with that poll. Let's give you some points. You're here, you're talking, you're interacting, you're getting points. Let's do this. Okay. 6 credit right there. When it comes to pivot tables, pivot charts, you make them in Microsoft Excel.
Wow.
Buttons.
Wow.
And here's Microsoft Excel. Excel is a program made, I think, in like 1991 or 93, early 90s, by the Microsoft Corporation. The first thing we're going to do is we're going to select all our data, and our data has been cleaned and organized. When you have a pivot table, what do you see that's wrong about this pivot table now, or this just data table? Brian is destroying his data right here. What do you notice is going to be very, very bad about this data? What do you notice is very, very bad? This is what do you notice about this data we're reviewing? What do you notice? One of the early notes we have. What do you see about that data? You're like, oh, you don't want to write your data like that. We don't do that here. What's going on? Who can explain what's going on with that data right there? That's not good for pivot tables. That needs to be cleaned. That needs to be fixed. Exactly. We have the same. We have different cases. Someone might have lowercase right here, one uppercase. Someone might have done this. So we're just going to unwind time. Really, you can't do that, Excel? There we go. That's what I wanted to do. Now we're back. We never made those changes. And it kind of uniform. I like that right there, Brad. Great stuff right there. I'll call you Brad right there. Yeah, it needs to be like, there needs to be uniformity to how we do things. That means like constant. So you think about a uniform distribution, good review of concept. Uniform distribution is constant, like one value. So we want these to have the same, they don't all have to be the same value, but they need to be coded the same way. So they have to be uniformly coded. And we've done that now as opposed to not uniform coding where someone capitalizes that because it is case sensitive. So we're going to go here, select all the data. We're going to go to insert and go to pivot chart right here. So when we go to pivot chart, it's actually going to make a pivot table to begin with, and we've already got it selected, so we're good to go. And I do have my Excel view up. Look at that. Okay. So when you do this, the number one, no wrinkles right there, nice and uniform, just iron it out. Iron it out. We love you, Joey. When you do this, the first thing you want to select is the value. That's what you're going to be looking at. Like, let's say we want to look at how many pets people own. We're going to look at how many pets people own. Now, it's actually making the pivot chart for me. I usually don't make that first. I guess I could have done pivot table. That's over here, right, on the insert. Yep, I could have done that. I just inserted the pivot chart to begin with. Well, there you go. So I already have my pivot chart. I love it because I'm going to make this anyways. So when we do this right here, we're actually looking at the counts of individuals, or the sum of pets, excuse me. This is how many pets people own. Among Stat21 students, there are 993 pets that are owned. And let's take a look at, you know what? Let's go to people's family economic level. So now we are looking at the pets that are owned. But here's the thing. When you look at this graphic, especially right here, why might there be more pets owned among middle class students? Why do you think right now there's more pets owned? And be very careful. I want you to look at the value field setting. Why do you think the middle class owns more pets? Why do you think the middle class owns more pets? The value field setting is super important because it's controlling the way we view this variable. Why do you think the middle class owns more pets? Like in the middle class, there was 423 pets owned. And why do you think there are more pets for students who are from the middle class? Why do you think that would be? Is it because middle class people just like, oh my gosh, we got to get a pet? Why is it? More people are middle class. Exactly. So we can actually change the value field setting, which is so very important. The value field setting controls the way in which we view things. The value that's being displayed here, number of pets, is currently the sum of pets, like adds up all the pets people have. But I can go here to count, which is counterintuitive. But when you're doing count, it's going to tell you how many observations there are in each group, so we can see where more people are. And it looks similar. Actually, if you look at this, middle upper jumped a little bit, but the middle class stayed the same. Now this means right here with the count, it says count of number of pets, but it has nothing to do with pets anymore, funny enough. It's just how many observations are in each group. There's 806 observations, which if we go back to our original pivot table here, guess what? 806, remember that 806 number? You go down here to the bottom and what do you see? 806. because this is a count of how many individuals are in each group. There's 323 people in the middle class. But if we go over here, we can change the value field setting again, which controls how we're viewing this. And we could go to something more interesting like average. Now we're going to look at the average number of pets for each of these groups. And what do you notice? Not too different. Not too different. Funny enough, we see it's a weird pattern where there's really no trend in this data. But you'll notice right here that lower class actually has the least amount of pets. Let's go here and change the decimal display. We can go over here to delete decimal button. And now we want to make this pivot table look all purty. What's something Brian could add to this pivot table right here? I can tell you the answers, but you should tell me the answers. What is something Brian could add? This pivot table is not complete. What are at least 2 things, and maybe a third? What are 3 things I could add right here to this pivot table to make it look way purtier? We can go right here, a title. Well, it has a title. We need to give it a title. And then we could add, so we call this like super cool title. I'm going to be changing my title, so I don't feel like doing a ton of titles. Because I'm going to change the graphic and I don't want it to look wrong. So that's going to be my super cool title. We're going to go here. We're going to go to axes, axis titles, and go here to primary horizontal and primary vertical. So now we have some axis titles. Very important stuff right there. Those are my super cool axis titles. And last but not least, what else are we missing? What else are we missing? And I kind of made it better by doing this. Kind of, it's almost like that Dimitri's going to answer right there. It's not quite it will be a contingency table of sorts because it's not the same as quite a mosaic contingency table. We need a data table, and let's go over here to this data table. You can kind of see the options a little bit small up there. We go to the data table, and now we have a nice purty graphic. You can actually do so many different things like changing the fill pretty easily. These things are very customizable. Did that not change the fill? That changed the outline. Cool, let's do it. So you can change them pretty easily and make weird looking graphics. We don't like that. Do that here. And with this right here, let's go look at the max number of pets, because that's kind of interesting. If we wanted to look for outliers, we could use a pivot table or pivot chart to look for outliers. Woo! Now this is the maximum number of pets that people own. So since this is in whole numbers, I might go over here and change it to whole numbers now, because there's no need for a decimal. If I say the maximum number of pets, I wouldn't say someone owns 12.2 pets because it's the maximum. Someone in middle class owns 33 pets. 33 pets. So this is at least one observation, but it could be less. The min would not be that interesting because the min's probably going to be 0. So we probably wouldn't want to view the minimum. It just, like I said, it's just the minimum number of pets for each group. We could divide this. I'll go here to maximum. Let's find out where that person's at. Let's go here and divide it up by, I'm trying to think of another cool variable to divide it by. Let's go by, where do you live from campus? Now, this is going to be a lot. That's too much like that. Sometimes flipping it helps. This is a bit, I would not probably make one that crazy. That's not a good, we don't want to do bad graphics here. Bad graphic. Go away. Go away, variable. Let's go ahead and do gender. Okay. Much smaller, much nicer. So now we actually have, I have the distance people are from campus. So now we have the distance people are away from campus, their gender. I agree, that is ugly. Watch out, your pivot tables can look kind of crazy. So, Kale, 100 points. You're free to say your thoughts. And you could change this right here. Let's go nice feminine color right here. We're going with, there we go. I like it. Nice masculine color right here. There we go. I don't know. How can colors? We got to go for a nice, it doesn't matter. You pick whatever you want. You'd be like, I'm going, is it doing it? Where's my outline? And I want to go to, I'm just making it. If you ask me to make my pivot tables, I'm going to make them the way I want to make them. You can just do anything you want. I just want to emphasize, once again, we teach pivot tables and pivot charts, but I think sometimes people don't do enough kind of making up their own sort of things on this. Because you can make it, be careful, because if you're like Brian, you're going to be a little too much at times. But you can do anything you want right here and give it different outlines and go a little too crazy. And someone says, you need to pull it back a little bit. One time I sent someone a pivot chart and they said, this is a little much. Went from Florida to Georgia. That's exactly the color scheme we're going for right there. But there's just so many options right here. For what you can go for. You can pick whatever colors you want, so it doesn't matter. Rock, what do you think?
It doesn't matter!
I made you all self-conscious. So right here, we're viewing the maximum number of pets that people own based on, and so you would think, I wish we knew more about this person right here, this unusual person who owns 33 pets, because I have two guesses of what kind of pets they own. This is one individual, at least one individual. It probably is one, because I don't think that many people own 33 pets. What do you think's the deal with that 33 pets? And then we'll do another topic of this. What do you think? What's the deal with those 33 pets? What do you think is it? What do you think's the deal with those 33 pets? I usually like to pick colors that are very diametrically opposed. Pretty easy to tell which groups we're looking at right here. Maybe a farmer. Could be cats. Could be fish. I had in my head horses, fish. I didn't think cats. But once again, we don't know the answer to this. But these are all possible answers. Easily could be a farm, could be horses, so livestock, stuff like that. All those different answers are quite possible, especially with the 10 to 30 minute drive. They're not too close to campus, so they wouldn't be in like the Ford area. Fish or bugs. Be interesting. They're like, I own 33 bugs. You're like, I mean, yeah, I guess that would count. Guess by the way we're collecting this data. And that really gets into how we collect data. All data needs what? Easy question on the test if that ever appears. All data needs what? Let's change the way we're viewing this. I'm going to disappear here so you can see it. We're going to change the way we're viewing the variable to see the average now. And when we look at the average right here, we're changing the way we view it. And this kind of makes sense. And you know what I can do? We rarely do this, which is kind of important, but we should do it more often, is I'm going to change the distances right here. This is going to reorder it. I do have a video on this, and it's really hard to get that little clicker thing. There's a way to do it better, but why do it better when you can do it the fun way? So I'm putting them in order of distance from campus, and we might see a little bit more of a relationship. Yeah, the relationship looks to be a little bit clearer here. Let's zoom out a little bit, bring this over here in its own world, and now we can kind of focus in on it, and we don't really need this anymore, so we can make this the primary focus of what we're talking about. Pretty nice graphic. What kind of, still got the thing on the side up. What kind of trends do you notice in this data? Context right there were the 100 points. Yep, all data needs context. So now we have this in order, pretty interesting, and it definitely confirms that probably what's going on right here. You know what's interesting? We see that females always own more animals than males on average, which is interesting in and of itself, that females compared to males, and no matter what group you're in, always own more. Like if you were to compare, like if you're doing your write-up, like it'd say like every time we look at females versus males, the difference is usually about 0.4 to 0.5 or 0.3 right here. Where females own about 40% more animals. So you see a difference right here, which could look at statistical significance with other sorts of statistical techniques. But the other trend I notice is here as you go up these groups, which I'm so interested, because I think people are counting like if they own pets from their family, which do you have a pet if it's your family pet? I mean, I thought they're my pets too. But what do you notice the trend right here? Because there's another trend in this data, which is apparent when I put them in order from this is the closest, this is literally on campus, this is right next to campus, this is within very close distance to campus, this is further, and this is very far from campus. So what do you notice the other trend is? So some points right there to that answer, and then we'll switch to probably chapter 6. Thoughts? People think the video is frozen when I do that. The trend in the data looks to be generally, and so it wouldn't, and so that, and I would say that's a trend. So great job right there, Kayla. I wouldn't say for certain, and here's the thing. Good answer, Kayla. We're going to make it an awesome answer. Generally, the further people are away from campus, we see on average that they own more pets. And it's not perfect because we don't see the perfect upward trend here. This is a little more flat. But generally, we see people at the further distances from campus owning more pets. For example, a 30-plus minute drive. For the females, own on average 2.9 pets, where the males own on average 2.5 pets. Once again, this is an average. And interestingly enough, those outliers, probably due to the large size of some of the groups. How do we look at the large size of the groups? We would have to go over here and look at the counts. So we could go over here and change the value field setting to see how many individuals are in each group. You notice right here, the on-campus has more. So even though if there are some outliers, we could look where the outliers are at. The outliers are going to be, yeah, this person's probably impacting the female average a lot. So that outlier there, and that's not that big of an outlier. The outliers would be in these two groups, and we'd have to view the maximum to look at outliers. If we don't want this person included, we say, we don't like you. I'm sorry, person. We can go over here and go to the filter. You actually have a filter. So you'd have to go over here to number of pets, throw that into the filter. And then we'd have to go down here to the person with 33 pets and say, bye. And what's really cool is everything automatically updates and you can see they go away. Do you really own 18 pets on campus? Really? We can move out this outlier and take a look. Now we get, and I love the way those update. Super cool, pretty easy to use. And this is very, very, very applicable to things you could use for later stuff. And that's why we teach Excel, is because this is going to update. It's going to show you the graphic. We just have the maximum values displayed right now. And we could go back once again to looking at the averages pretty quickly right here by changing the value field setting. And we still see the trend that we were seeing. It's even flatter now. So that right there. Other questions on the exam are going to be mixture multiple choice, fill in the blank. And exactly the exam will look like the Canvas content. So there will be multiple choice, fill in the blank, true, falses, lots of whatever the Canvas content looks like. That's what the exam is going to look like. So make sure you're doing those Canvas contents. Let's take another vote right here. We're going to head back to the main screen. Great question, Vincent, right there. Let's head back to the main screen and do more questions. Okay. What to do now? Okay, so we have a new vote going in the chat. Chapter 6. We did Chapter 5 to start. We can still do Chapter 5. Chapter 5. Now, Chapter 1 through 4, don't take them for granted. If you pick Chapter 1 through 4, I might narrow it down. But take a vote in the chat. Like, exactly. Well, yeah, no, there are some questions. I mean, there's only so many ways to ask questions. I was trying to come up with as many different true falses as I could during class today. Literally tried to, like, break my brain for every single true false I could ask for correlation. Like, I tried to ask, like, everything I could think of true false for correlation. And I'm like, well, some of these are going to be very similar to the exam because if you make up a true false question, you think of every single true false question you could ask. Because there's only so many concepts with correlation. Correlation has the concepts of what are the 3 conditions for correlation. Who knows? Quick review right here on this screen. People are missing if they're waiting for the next part. Pop into it. Oh, yeah, looks like correlation's winning. I'm going with some correlation right here. Let's see if you know the big concepts for correlation. Let's go ahead over here and do the main screen. Okay, big concepts for correlation. Chapter 6, big concepts. What are the conditions for correlation? Chapter 6, big concepts. Oh, we gotta do it this way. Big concepts.
Chapter 6, big concepts. Big. Okay, let's do this.
So what do we got? Chapter 6, big concepts right here. What are we doing? QQ, straighten up. No outliers. Demetrius knows right there. What's up? You got this. QQ, straighten up. No outliers. No, the placeholder is just a placeholder. No worries about that. Placeholder is just there to hold a place for the exam. QQ, straight enough. Not straight enough. Straight enough. No outliers. So let's say Brian asks you question. Let's do a question related to it. I need to go smaller. So that's a big concept. So here's a question. Brian wants to analyze the variation between students who attend the review and those who don't and their exam score. Can he do correlation? Yes or no, and why? Ooh, that's a big concept right there. So here's a question right here. Brian wants to analyze the variation between students who attend the review and those who don't and their exam score. Can he do correlation? And then explain to me, because people are probably wondering what this QQ, straight enough, no outliers is. What's going on right there? Exactly, Josephine. I like that answer. No, it's not QQ. QQ means 2 quantitative variables. So when you look at this right here for this problem, they aren't both QQ exactly, or they aren't together QQ. I like our Catherine. Some points were there also. Great answers. Attending the review, not attending the review is going to be categorical, and then their exam score is quantitative. So does anyone know what graphic this would make? I'll give you a hint. Let's throw some 100 points if you can tell me how could you display this graphically. Take a moment right here. Put on my chill music. So what graphic would this make? What am I gonna do? I'm gonna do something really quick right here. A few seconds while you figure that out. I've been wanting to do this for forever, and I forget. Stream OBS. Let me put this in here. been wanting this to be a button. Source. And let's say graphic. We're over here on the desktop. Oh my gosh, I can do it now. Look at that. Got a button for it. Side by side box plots. Side by side box plots. Or stacked histograms. Great job right there. Side by side box plots or stacked histograms because it is categorical quantitative. If you're looking at my graphic once again, notice how it's going to be the bottom left, right. Can't point to it because that's going to be when you have a quantitative y and a categorical x. We want to understand students' test grades, making it the y variable of interest. So you're over there on the quantitative y. I can't reach into it. And then you would be in the categorical x. So you're in this one pointing towards it right now. Only when you have two categoricals are you doing mosaic plots, contingency tables, and then there's your scatter plot time plots for correlation, which you notice scatter plot time plots, put those two letters in the chat. Scatter plots and time plots, which you should know those, are both what? And you can even tell by the color coding, the blue ones are quantitative, the green ones are categorical only. So the scatter plots and time plots are only for two quantitative variables. It just depends. You can do different, like the x variable is over there on the left side. If you have a quantitative x and a quantitative y, you're doing scatter plots, time plots. If you have a categorical x and a quantitative y, you're doing the side-by-side box plots and the stacked histograms, what I'm pointing towards. And then this one right here is two categorical variables. Does that make sense, Kayla, right here? If you go this way, you see how that goes to a categorical this way? And if you go this way, this goes to a categorical. Does it make sense how to use this? Who understands, yes or no, how to use this graphic? And up at the top, you have the single variable displays where there's no x variable, there's just one variable. So the x variable is blank for those over there. On the very top is a univariate display where we're just looking at histograms, box plots, stem and leaf, dot plots, quantitative univariate, and then the bar charts. And the green is only categorical, like either one or two variables. And then the blue is only quantitative. So there's color coding to help out here. The black is a mixture. This one we don't do. We do logistic in 320. It's worth mentioning, but we won't be doing logistic in our class. So good stuff right there. That's got it. Good job, Cami. Great to see you here. Let's throw some points for Cami being here. 50 points, Cami. So we want to make sure we have two quantitative variables. So this would be no. Needs to be QQ. Let's say this. Question. Can we use, this is a little bit of a complex one. We'll have to draw it out, but I want you to think complex right here. Can we use correlation for baking a cake up to 10 hours and the score people give the cake? So you have to have a little baking knowledge right here, and you have to think about how this works. So we're still in the big concepts of QQ, straighten up, no outliers. So can we use correlation for baking a cake up to 10 hours and the score people give the cake? Let's go look at this. So if we bake a cake up to 10 hours, I want you to think what's going to happen right here. So this is hours, we bake a cake, and this is the score. People are going to rate our cake and how it looks and how it tastes and give it a score. So what do you notice about this right here? I maybe should have put like 7 hours. So can we or can we not? Can we or can we not? Or should we? Maybe it's a better word. So it is a time plot. Demetrius right there. It is a time plot. This is a time... Demetrius, that's worth 100 points. One more points at that. This is a time plot. As long as I put something far out here, we're good on this. Both variables are quantitative. It does pass QQ. And this one requires you to think over what's going to happen here. Good job, Vincent, right there. Extra points, Vincent. It is QQ, so it is both quantitative variables. Anyone here ever bake a cake? What's going to happen if you eat that cake, which, I mean, I'd be good with it. What's going to happen if you eat that cake after 0 hours of baking? How are the judges going to rate our cake? How are the judges going to rate our cake if we put it in the oven and we just take it right out? We say, okay, in the oven, out of the oven, 0 hours. What scores? Catherine sees where this is going. This is a good, like, you'd have to theoretically draw it. They're going to be like, nah, your cake is horrible. These are a bunch of cakes that have 0 hours. Now, what's going to happen is we bake that cake. I don't know how long to bake a cake. Maybe 2 hours, something like that. What do you notice right here? It probably would fall a lot quicker. What do you notice about this graphic? Ron, I'll eat some cake soup. Brian's the one judge who says, best cake ever. My mom stored cake batter in the refrigerator one time. I'd literally go with a spoon. Salmonella. I'm not scared. So what do you notice right here? What are the big concepts we want? Ooh, I actually like where Brian is on this because Brian is the third concept. And here's some key concepts also. It's curved exactly. So what are we trying to illustrate with this one? QQ. Straight enough. Is that straight enough or not straight enough? It's not linear. Great job right there, Vincent. Some points. It's not straight enough. So when we say straight enough, it doesn't have to be perfectly straight. You could have a relationship right here that looks something like this right here. Do you think what Brian's trying to draw is straight enough? Do you think that little mini diagram over there on the right is straight enough? It's not perfectly. It's not perfect. But do you think that right there is straight enough? I like what Mia's saying right there. That looks straight enough. And that's what we mean by straight enough. It means like, yeah, it's pretty good. Yeah, it's pretty good. Is this in the realm of pretty good, yes or no? Is this like, yeah, it's straight enough? What you want to do is you want to try to draw a straight line. You take a straight line and you say, does it kind of follow a straight line? No. No, follow that. It does not. Interestingly enough, it's kind of flat if you were to put a real straight line through it. So correlation here should be close to what? Here's the drawing around it. Correlation for this should be very close to what? This will be some good key concepts also on this. Correlation is very close to what? Points. Close to 0. Demetrius, excellent work. Correlation is going to be close to 0. Let's ask another question. True or false? Hours is not associated with score. True or false? The hours you bake a cake is not associated with the score. It's a good concept right here. True or false? The hours you bake a cake above is not associated with score. The hours you bake a cake is not associated with false. With score. Why? You are correct. Why? I'm always reading the screen. I always read everything being typed. When you type it, I read it. So why? Explain to me now. Cracking up Kayla. That's points for cracking up Kayla right there. Still has a relationship, just not... Demetrius, excellent work. Demetrius, just love it. Excellent work. We're having fun day in office hours. Because it's associated, but just not correlated. Exactly. So what does association mean? If I know how long you bake the cake, it gives me information about the score for the cake. Like, this is a whole bunch of different cakes here, baked for a whole bunch of different times. Like one of these little dots right here represents a judge's score for a cake. Like, that cake was baked a little over 4 hours and then got a score like of a 7 or 8 or something. So a judge is going to try a cake that was baked for a certain amount of time and then give it a score, and then we can plot the judges' scores, and we can see judges are generally giving higher scores. Kind of like it affects it, that it gives you information. I think that's one of the best things to do, and if you take 320, it's literally how we say it, is that knowing X would tell you something about Y. It would narrow down the values. So you don't know for certain the score of the cake if I tell you it was baked 4 hours, but you would tell me if a cake was baked for 4 hours, you would probably expect that cake, and you might say, Brian, that's not how it works, but if a cake was baked for 4 hours versus a cake that was baked for closer to 8 hours, you would tell me these cakes in A versus these cakes in B, you would expect the cakes in A to get a what score? We could even compare that to cakes in group C right over here, and you could say, yeah, there's an association, because if I know how long it is baked, it's going to give me information. It would narrow down the values. Like, generally, these cakes that are baked about 0 to 1 hours are not getting high scores. People are hating them. Generally, these cakes that are baked closer to 4 hours are getting higher scores. And so by knowing how long the cake is baked, we would have right here an association. So it is false that there is no association. It's just that there is not a linear association. because the linear strength is measured by correlation, which ranges in values from -1 to 1. So another key question right here. Let's go to another big topic. We're just doing big topics right now. The 4 ways to describe bivariate quantitative relationships. What are the 4 ways to describe? Big topic right here.
Big topic.
So what are the 4 ways to describe bivariate quantitative relationships? The 4 ways to describe bivariate quantitative relationships are what? Once again, remember, I can just say everything. I can just hit the material, but if you're here practicing, it's going to be better. Then you get to the test and you're like, wait, there's 4 ways to describe this. And you're like, wait, I said it during class. I wrote it. I like it right there. Strength, direction, form on you. Be careful, be careful, be careful. You've mixed a few together. So, Megan, you've mixed a few. Here, I'll contrast. You've mixed a few. Megan, I'm still throwing you 100 points. Megan, first answer going out there. You're missing 1, Kayla. You're super close. Yep, you got it. It is strength, direction, form, unusual features. Unusual features is just those outliers right there, things that don't follow the trends. Megan, don't worry. Megan, I'm throwing another 50 points. Don't worry. That's what we practice here for. If you got to the exam, you might not know it, but you're here practicing, and that means you check your knowledge, and you're like, yes, wait, it's strength, direction, form, unusual features. It's just the way I memorize it. And just think, if you have a scatter plot right here, let's go over the concepts of this. Tell me the easiest one. Let's do the direction of this. Just tell me the direction. There's only a few answers for direction right here. Direction is going to be positive, negative, or neither. So that's going to be positive. Boom. Wait, I'm going to highlight it so I can delete it. It's going to be positive. Probably the easiest one to do. A lot of times we'll start with direction. Let's do form. The 2 types of form right here are either it is a line, so linear, or nonlinear. I mean, you could go into more classifications of nonlinear, but the reason we care about linear is correlation only measures linear strength of associations. So this is linear. Excellent work, Kayla, right there. This is a line. So when you get to unusual features, you want to say if there are outliers. And so this right here would be no outliers. So we could put like which this is actually good. I should put in green, like no outliers. So we would say here, no outliers. We'll say no outliers. Last but not least, we have strength. And what is strength? Strength is a weird one, which usually people get a little bit confused on, one of the more complex topics. Strength is what it is around the what. Strength is what it is. And I like right there, moderate tight, so that'd be pretty strong-ish. Strength goes from -1 to 1 when we look at linear strength. And it is we're looking at linear, how tight am I right there, remembering how tight it is around the form. How tight it is around the form. Correlation only measures linear strength. Correlation only measures linear strength. So the value of R that we assign this, if we look at the value of R on this, the value of R for this might be something like this. And by seeing it's 0.82, we would know what right here? Mia got it. Yep, how clustered it is around the form. And so the 0.82 tells us that this is a fairly strong positive, because it's positive, correlation that is somewhat linear. It has to have some sort of linearity to achieve a correlation, at least to this magnitude. But just tell me here, what would be the value of correlation? What would be the value of correlation for this? So here I've changed my graphic. Wait, that's still wrong. 2 seconds. I want to do this right here. There's a point. Okay. That's better. That's about right. Okay. What would be the value of correlation now? And I'm purposely trying to do this. There you go. What would be the value of correlation? Yes. So now we've changed the what of this. What have we changed of this? What is the usual start of correlation? Oh, yeah, don't worry. Those good question, Megan. Everyone's going to have different ways of describing it. The good news is we could argue where it's strong. I do it at the negative, right? We could argue where it's strong. I generally do like 0.75, but someone could say that's moderate strong. But we can't argue about this number. So someone could say that's a negative, moderately strong, because it's closer to -1 linear correlation. with no outliers. But people will argue over the adjectives that we put to it, like is it moderately strong, is it strong, is it very strong? But no one can argue over this number because that's a mathematical computation. So don't worry about the subjective words. Just realize closer to, and we'll show the graphic, closer to, gotta find it. Closer to -1 is strong, and closer to 1 is very strong. You won't calculate this on the exam. Good news right there. You won't be calculating this on the exam by hand. So you won't calculate it on the exam by hand. How about this, though? What could an outlier do to this correlation? If we were to put in an outlier here, what would that outlier actually do to this correlation? So what you want to do, and this is a trick, is you want to draw an ellipse without the outlier. And there's the strength. And then you want to draw an ellipse with the outlier. What do you notice? And it can do anything. And it's going to bring it closer. Do you see from the red to the blue, with the blue right here, the R is going to go down. It might still have a downward trend, but the R is going to be weaker, and it might be something like 0.48 or -0.48 because it's closer to 0. It looks more like a 0. It gets wider. It's more like a 0. It's not as tight around the form. So that outlier there is making it weaker. And depending on how far out the outlier is, and we like to show this, depending on how far out the outlier is, it can pretty much do anything. So outliers can really do anything to correlation. I can't state that enough. That's why we say no outliers. We don't like those outliers. Because if we have an outlier, it can make a weak correlation strong, a strong correlation weak, a positive correlation negative, a negative correlation positive. R, what are you doing? I'm trying to load and you're not loading. R, come on, R, you got this. But outliers can do anything. Anything is possible with outliers if Ryan eventually gets his R to load. Don't save selector right there. Oh, it seems so nice outside. Refund issue. Thank you, Amazon. I appreciate that. Let's look over here just to see once again that outliers can do anything. And here we go. Here's what outliers can do. Take a look. This distribution right here is perfect positives, maybe say, but I need to double check with the z-scores. You won't have a z-score chart. You will have, and check out the start of this video. We did some chapter 5 problems. Great questions, Cammy, right there. We did some chapter 5 problems just like what you could see on the exam, like Canvas content. So take a look. This is perfect positive. You add in one outlier and boom, the correlation is basically 0. This is perfect positive correlation here again because the value of R, you add in one outlier and guess what? It's now negative. You have right here a correlation of basically 0. But I want to know something. Tell me, with this graphic right here, is there an association or no association? What do people say with this graphic? Look at the correlation value. I'm trying to make it 0. Is there a correlation right here or no correlation? Correlation right here. Oh, we haven't got over 475. Oh, good question right there, Caleb. We'll have to do that. We went over that yesterday some, and we did at the end of class. Check out the end of class because we're getting near the end today. Is there, let me ask you this. Outlier can change direction. Yep. Because outliers can do anything. So, true or false, this has no association. Kale's on the right track. True or false, this has no association. It's like a question we just did earlier. Take a screenshot of it. Bring it over here to our document and talk about it. We have actually found the value of the correlation. So we can delete all our work right here. Say bye-bye work. And we actually know the value of the correlation. So let's go over the strength, direction, form, unusual features of it. There it is right there. You can edit your image with a little crop. Not that. I want to go to crop. Where's my crop? There we go. So this has no association. Well, let's look at it. What is its direction? What is its direction? What is its direction? What is its direction? Tell me its direction first. What is its direction? Neither. It doesn't really have a direction. It's neither. It's like none, no real direction. It goes up and down. It's neither. Does it have outliers? Yes or no? Does it have outliers? Yes or no? Does it have outliers, yes or no? It does not have outliers because its form is nonlinear and it has like a parabolic form. What is its strength? So how would you describe the strength of this? It does not have outliers. Sorry if you see that red dot right there. That's just, let me make it so it's not a red dot. Still the same thing. I just want it to look more like uniform. It's pretty strong. It's pretty strong because of how tight it is around the form. We drew the form in, has a parabolic form to it. So we can see it's very tight around the parabolic form. And that's, you're saying to me it's a very strong relationship right there. So everyone's saying it's very strong. So let me ask the question again. True or false? This has no association, which is the same thing as saying relationship. True or false, chat? I want to see some capitalized answers right here. True or false, this has no association. So close. It's going to zoom out if I do it. True or false, this has no association. False. Why? Explain. You are correct. It is false. This does have an association, but the value of R you see over here, which is calculated to be 0, tells us that what? R only measures the what? It's changing my colors. R only measures the linear strength, which is very weak. It doesn't follow a line well. So R is only measuring the linear strength because it has a strong relationship. Exactly. So it doesn't have a good correlation right here. There's no correlation because the linear correlation would be basically 0. But great job, Vincent, right there. Excellent work. There is no linear correlation right here. There's no linear association. There's a parabolic, and the correlation is not picking up on that. And Kayla pointed out earlier that outliers can do anything. So hopefully this is making more sense right here. It's very strong. And we will be we'll be reviewing more here in a little bit. So come to today's class, and we'll be doing lots more review. What shall we do? I want people to say in the chat what you want to do. Okay, let's do this 80s serious music. What topics do we have? We got 13 more minutes, and then I need to go look at emails. The emails. Your call. We'll see what chat says. We got 13 more minutes, probably enough time for a few more practice problems. That was some big concepts from chapter 6. So hopefully that felt like review when you're like QQ straight enough, no outliers, strength, direction, form, unusual features. Chapter 5, Mia's saying we could do, I think that was like in second place. We could do probably at least 1 or 2 more chapter 5 questions. What are people saying? Mia says chapter 5. Mia voted first, so Mia's vote's very powerful here. Unless all of a sudden everyone was like, no! More true falses? We can do some chapter 5 true false. We can blend the two together. Let's go do some chapter 5 true false. It's all the chapters 1 through 6, and pivot on the exam, kind of evenly spread out. Let's do some chapter 5 true and false. I want to say this, and I mean this. Make sure to come to the class after the exam because we're starting regression, and regression is no joke. You thought chapter 5 was not fun. If you go, I'm just going to go with the flow. If you don't come to the class after the exam, you'll be like, I have no idea how to do this regression stuff. Who is feeling pretty decent about chapter 5? Like, you feel pretty good. And the only reason I bet you feel pretty good is because you've been practicing it. And if you get to those chapter 5 questions on the exam, and you're like, that one's easy. That one's easy. It's because you were practicing it a lot. Because you were coming to class, you're coming to the reviews. And if you don't feel good on them, then be like, I need to come to class. I need to come to the reviews. I need to do the quizzes. I need to do the homework. So please, if you're hearing this, we're going to break the cycle. Emma, so proud of you right there. And if you don't feel comfortable on these, homeworks, quizzes, Canvas contents, it's all about repetition. Here's the last thing I'm going to say. Does anyone here play an instrument? Who's my instrument people here? Anybody is Brian Instruments people? Who's Brian's Instruments people? And I want to know this from you. How many times do you practice a song to be able to play it well? How many times do you play a song? You want to play Fur Elise, Rondo alla Turca, Moonlight Sonata, songs right there. How many times do you play that song? You might play a song even a couple hundred times. Now, we're not going to do these problems a couple hundred times, but you're not going to learn how to play a song by playing it one time. You won't solve one chapter 5 problem or chapter 7 problem, not on this test. Chapter 7's not on this test. You won't solve one chapter 7 problem and know how to do it. You'll have to practice. And then eventually you'll get to where it'll be easy. Where you'll have that muscle memory in your mind. So let's do some true false. Or practice. Here we go. I'm gonna try to write 5 questions right here. Chapter 5, true false. Okay. These are all true false. Okay, let's start with the first question on the screen right here. What do people think right here? The normal model and the empirical rule can be used for all data. 80th percentile. Yep, we could try to do that next year, Madison. You got it. We'll go back. Go back and check it out. That's kind of... So we'll do that after this. This is false. Why? Why is this false? Explain. We can't use the normal model and the empirical rule for all data. The data needs to be unimodal and symmetric, i.e. normally shaped. So the normal model, the data needs to follow the normal model. So if our data looks normal, we can use it, and we have ways of doing that. So we get in here to the goodness of fit test. The goodness of fit test, and we did cover this during yesterday's office hours, and we covered it during class today. The goodness of fit test assumes that the data is normal to begin with. True or false? The assumption for the goodness of fit test is that the data is normal to begin with. We'll do a little review on what this is here in a moment. The assumption of the goodness of fit test is that the data is normal. Wait. Oh, it says I might have said... Oh, yes, that's right. It assumes it is normal. I might have reversed what I was saying. I'm hearing my brain say what I said. I know, right, Mia? Sorry if I'm thinking of these questions and reading them as I'm saying it. So I think I literally said the right thing because that is the null hypothesis. The null hypothesis is that it is normal. So I think my brain defaulted to what the right answer is. The assumption for the null hypothesis for the goodness of fit test is that the data is normal. And we do have that written down, I believe, somewhere over here. We were showing that today during class. Here, we'll rewind time on this to where we were talking about the goodness of fit test, and we will show you right here the goodness of fit test and how it looks. So when you are doing a goodness of fit test, the assumption for the goodness of fit test is that it is normal, and if your data looks normal, this is a likely or unlikely result. If your data looks normal and you assume it's normal, what you saw was likely or unlikely. Be careful, that is 0.05, but it's saying the p-value is greater than 0.05. So if your data looks normal, and you assume it's normal, that was something what to see. Don't even look at the numbers, just think what I'm saying. If your data looks normal and you thought it would be normal, that was something likely or unlikely to see. So just don't even look at the numbers. Think, if my data looked normal and I thought it'd be normal, that was likely to see. Catherine, right? Get it? Yeah, that's exactly it right there. I think the numbers looking at it confuse people. But if I'm saying we assume the data is normal, and then when we look at the data, it's normal, that was likely to see. But if we assume the data is normal and it looks like this, down here, this would be a what likely result? Think small probabilities, that's unlikely. And let's look how this looks. Here is a histogram of normal data. Here it is. This is a histogram of normal data. So if I were to run a test on this, would my p-value be high or low? Remember, the test assumes that the data is normal. So if I run a test, was this likely to see that the data is normal? So do you think my p-value will be high or low here? Because my data looks kind of normal. I'd say the data looks pretty normal. Was this likely to see given the data is normal? This result, was that likely to see or unlikely to see? We shouldn't see this. Is this likely or unlikely to see? This right here would be very, very what? It'd be very likely. So the p-value should be what for this? When I run this test, the p-value is going to be very what? And I do this so we can run the test pretty quickly. It's going to be very high. Look, here's a high result. But if I change this and I do an exponential distribution, which has a totally different shape, very easy question right here. You got this. What way is this skewed? Right to the high, left to the low, whatever way that monster man's tail goes. Right to the high, left to the low. What way is this skewed? Right to the high, left to the low. That is definitely right skewed. If a question asks that, and what do I mean by high? These are the high portions of the numbers, and low, and great job everybody practicing along right here. I think we've picked up a few more people. This is the high side, this is the low side, and right to the high, left to the low, whatever way that monster man's tail goes. So if the data was truly normal, like we're saying like, no, this data really has this sort of shape. It's really like a unimodal distribution. It really comes from this unimodal symmetric distribution. Should our data look like this red distribution right here? If our data truly is normal, should it look like this red? This result right here would be what likely? Seeing the red distribution sounds very what? Like we're saying, no, our data really is normal. It's just weird that we got this. This sounds like a what likely result to see this red distribution. That red distribution sounds like a what likely result. Like seeing that would be very what if our data is normal. With the assumption our data is normal, this would be very what to see. It would be unlikely. And take a look at that p-value. That p-value right there, if you're wondering, is going to be this right here. That's what the p-value is. It's ridiculously impossible. So we're saying this is basically impossible to see if our data is normal. So we would reject that the data is normal and say we have evidence the data is not normal. And that is what the goodness of fit test is doing. So the goodness of fit test assumes normality. And if the p-value is low, so a low p-value on the goodness of fit test means we accept the null. We only do two things with the null hypothesis. So we will reject the null and conclude the data is, at the p-value, low p-value, we'll conclude the data is correct. So we reject the null. There we go. We either reject or do not reject. Low p-value means reject the null. When the p-value is low, reject that null. When the p-value is high, just let it fly. Just let it be. Don't reject it. So that is false right here also. Like all my true falses are always false. It's just more fun to explain the concept. False. Normal probability plots can be used to assess normality. True or false? Normal probability plots can be used to assess normality. True or false? A normal probability plot can be used. I'm throwing 100 points. Got a lot of people watching right now. Throwing those points to you. A normal probability plot can be used to assess normality. Yes, very true. That's how one of the ways to assess normality right here. So we need to go look at one. I like using R because I can make these plots very quickly. I can go here and show you what a normal probability plot looks like by just writing the code and giving you a normal probability plot. How do normal probability plots look that are normal? For a normal histogram, a normal probability plot should look very what? For a normal histogram, a normal probability plot should look very what? A normal probability plot here. The plot, the probability of normal. Kayla remembering my help for it. Normal probability plot plots the probability of normal. Just read it backwards, Kayla. That's worth some 50 points. And it should follow the straight line, and that's a normal probability plot right there. But if it's not normal, and I'm just showing what it might look like, our histogram, once again, might be skewed, and here's a not normal distribution, and then you see it does not follow the straight line. So once again, if it does not follow the straight line, it's not normal. This line right here is basically, this is the normal. Like, this is what normals look like. And the distribution it came from was not normal, so it does not follow it. Compare that to this right here, which looks kind of normal. You say, well, that's a little gap right there. Well, histograms have bins, and bins are weird. And so this really follows it. Does it follow it perfectly? No, but it's within our lines right there. So it's pretty good. That's pretty good. So that is very true. There is no area outside the curve right here. True or false? True or false? There is no area outside the curve. There's no area outside the curve. True or false? We'll end with this. Very false. The curve goes to infinity. Goes to negative infinity. And infinity. And you can use better calculators. This is why we don't use z-tables. So you can use calculators right here to find the area outside the curve. Because if we go here and go to q norm, I think it is, we can find the area below its p norm. I always get those confused. So we can find the area below. And now we want to get 1 minus is the other side. Oh, we can just times this by 2. Oh, well, let's do the inside. 1 minus is the other side. And let's take right here and do 1 minus the both sides. There we go. Perfect. So let's just call this value. This is why I love coding. Because I can go right here and let's times this by 100. And I want to show you this. We'll end with this right here. This should do it. Oh, I didn't put my thing. Wow. That's a basic error and I made it. What am I showing you right here, right now with this code I just wrote? And you're not meant to write code. It's a good way to show you. What am I showing you by doing this right here? What is Brian calculating for you? Take a look at what we have on the screen and tell me what we got. What do you notice right here? And it's a more exact calculation. If you look at it, what did Brian just calculate for you? 68. What did I calculate for you? I just showed you the what? Have you ever seen these numbers before? Have you ever seen those numbers? Anyone ever see those numbers before? The 68. Not p-value. Well, you can use this for p-values. This is the empirical rule. 68, 95, 99.7. So I'm using this right here to show the empirical rule, the normal curve values, and you can actually see the more decimal places because the David M. Lane and applets like this will get you a more exact value. Madeline, great job right there, knowing your 68, 95, 99.7, and this will get us more exact values. That's why we don't use z-tables because there's much better ways to calculate than z-tables that will get you exact values. The next one is 99.99, and so if we do this 99.99, and then the next one adds 2 more 9s, it's easy to remember because now it's 99.9999, it's 2 more 9s. And then the next one adds 2 more 9s, 99.999999. And so now we check. Oh, it says 100. How dare you are. How dare you do that to my numbers. Don't you do that to my numbers. There we go. Here's the 6 9s right here. And then on the 7th one, which is so interesting. This is Brian being a huge nerd. On the 7th one, it's 99.9999999. It has 7 9s. Kind of a good way to memorize it. Am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, no, it's got 9 9s? Oh, Brian didn't know it. Brian got it wrong. But this just shows there's more area outside of positive and negative 3 as we go up in values from 1, 2, 3, 4, 5. But most all of the data is within positive or negative 3 standard deviations. And Brian was wrong. He's got to update his knowledge right there. Haven't checked those numbers in a while. But that's why we only really care about plus or minus 3 standard deviations, because plus or minus 3 standard deviations is pretty much all of the curve. So I'll remember on the 7th, it actually adds an extra one, not that it is only one more. Maybe Wikipedia was wrong, or maybe ours wrong. Ours shouldn't be wrong. But I think that's got it. Really good stuff. Brian Can't Math. 20 points right there for Brian Can't Math. If you did have there was a question. I want to make sure we mention it. People were asking about the 80th percentile when you have the middle 60. If you were to have the middle 60, just a quickie question right here. If you had the middle 60, then where, and this is just a real quick one, where is the 80th percentile on this? Because if this right here is the middle 60, then what do you know is outside of this? If you have the middle 60, then where would the 80th percentile be? Well, wouldn't there be 20% right here? And 20% right here? So can you tell where the 80th percentile is? Where would the 80th percentile be? The 80th percentile should be where 80% is below. I might leave it at that. I think you see it, right, Mia? So the 80, just make sure to draw on your graphics and draw everything you can. And I do want to point this out. If you're here and you still have lots of questions, well, one, we'll be reviewing in class here in a moment. I'll send out that link. But you can also go here to the review material and check out where I work all these problems and show how to solve these things on this page. Mubot's going to put it in the chat, but you can see a lot of different problems we're going to be reviewing here soon. I'm going to go check those emails. So make sure to email me. We'll be back here reviewing in class, sending that announcement out. Class in 15 minutes. Bye for now, everyone. You got it. You got it.